The last type of test that we're going to use to figure out if a series converges or not is called the ratio test. And basically what it says is if you have a series and the terms can be actually positive or negative here as long as just the terms aren't zero, you're going to take the n plus first term divided by the nth term. All that means is you take the next term over, that's your n plus first term, divided by the previous term, and if the limit of that is less than 1, then we're going to say it converges. What this really is saying is that the numbers are getting smaller. If you take that ratio and it's greater than 1 or infinity, then the series diverges because those numbers are getting bigger. If that limit is equal to 1, then it's going to be inconclusive. So we're going to have to resort to another test. Okay, so step 1 on the ratio test is set up your ratio. So limit as n goes to infinity. You take the n plus first term, so anywhere there's an n, you replace it with n plus 1, and you're going to divide it by the nth term, which is the same as multiplying by the reciprocal. So here's my setup. Next, let's try to simplify things before we take the limit. So this is really 2 to the n times 2 to the first. So the 2 to the n piece will end up canceling. This is really n plus 1 times n minus 1 dot dot dot, so it goes on forever. N factorial is n times n minus 1 times n minus 2 dot dot dot, etc. So notice all the factors from n down are going to cancel on the top and the bottom. So really what you're left with before I take my limit is this. You have 2 on the top and you have the n plus 1 here. Now when I take the limit, plug in infinity for n, this limit is 0, which is less than 1. So we can say this series converges by the ratio test. Okay, let's try another one. Okay, same thing. Start with your setup of the ratio test. Limit as n goes to infinity. Make sure you do have the absolute value bars. N plus 1 everywhere. Over 3 to the n plus 1. Dividing by the nth term is the same as multiply by the reciprocal, so flip that. So here's my setup. Again, I'm going to go ahead and simplify a couple things before I actually take the limit. This will leave you with a 3 to the first on the bottom. Okay. This will leave you with a 2 to the first on the top. These pieces here, these do not simplify. If you multiply this out, you have n squared plus 2n plus 1. That n squared does not cancel. Okay, so you're going to have to leave it as is for right now and don't multiply it out. I said we have a 2 to the first left in the top. I still have that n squared and I have a 3 to the first here. Okay, now when I take the limit though, what happens when we take the limit and the degrees are the same? We do the ratio of the lead coefficient. So this limit will be 1. I still have a 2/3, so this whole limit becomes 2/3, again, which is less than 1, so we're going to say it converges as well by the ratio test. Okay? Okay, let's try one last one. Okay, so same thing, I'm going to set up the ratio test. Limit as n goes to infinity, -1 to the n plus 1, square root of n plus 1. If I plug in n plus 1 here, this is really n plus 2. Flip it. Start with this. Okay, now a couple things. Notice this is an alternating series, but you can use the ratio test because you are taking the absolute value. This and this, you have a -1 to the n times another one, -1 to the first. This will cancel. -1 to the first is obviously just -1. But because you're taking the absolute value of it, you can go ahead and take the absolute value of -1, which is 1, and just put it on the outside. So this is really just 1. Okay, now let's go ahead and take this limit. I'm going to take this limit right away. So degree on the top is n to the 3/2, right, if you actually could multiply this out. Degree on the bottom is also n to the 3/2. Degree on the top and the bottom is the same. We take the ratio of the lead coefficients, which in this case happens to be 1. So notice this is inconclusive by the ratio test. You have to find another test to use. Really what you should be doing is doing the alternating series test on this one. Okay, so one way to determine whether the ratio test is going to work or not is you should typically be looking for exponentials, So something raised to the n power and factorials. Those are the type of series where the ratio test works. When you have simply things raised to powers, the ratio test typically will give you an inconclusive result.